Hello, this is Dr. Ryan Johnson with the class Introduction to Statistics, and today we're covering section 11.1, which is two quantitative variables, scatterplot and correlation. So for this section of the worksheet, our research question is involving tennis players and wondering if the heights of the winning players might be changing over time. So if there's an association between time and heights of the winning players. And at first, we're not really showing you the data. There's a link to the original website, sports website that originally published this. But we're not just even looking at the data, we're just asking you to answer some questions about this just from knowing that research question. So knowing that research question, what is the observational units in this study? You should be specific. And then what is the explanatory variable? Is it categorical or quantitative? So this is again, good review. What is the response variable? Is it categorical or quantitative? Now we're in the two quantitative variables section, so that's a good hint for those two questions. So then number 4, in your own words, explain what it would mean for there to be an association between the explanatory and response variables in this study. Try to use like small words, like things how you might explain to somebody who hasn't taken a stats class before. And then our next question is number 5, is the study an experiment or an observational study? That should be a review question from chapter 5. And so now we start with just looking at a little bit of the data. So here shows some of the first years of the data and then some of the most recent years of the data when it was collected. So for number 6, use your common sense and knowledge of the world to name one possible reason some of the heights are the same for different years. And then, so sometimes you get like the same height multiple years. Why would that be? And then use your common sense and knowledge of the world to explain maybe one likely reason that some years have multiple heights. Okay? Now notice that early years don't have multiple heights, but later years do, and that's a good clue. Okay, now the key idea that we're talking about today is scatter plot. So we're going to have to look at the data. So you can find the data at here, but it might be easier to just go to applets and then the correlation regression, and then you can just select the data Wimbledon. And then once you click use the data, then we get our scatter plot. Okay. So the question for number 8, it was the question is kind of the second paragraph there. What variable is on the x-axis? What variable is on the y-axis? If you want to reverse those roles, press explanatory response button above the data value. So what's on the x-axis, what's on the y-axis? You can always swap them, but we don't want to swap them. We want them that way. All right. Create a rough sketch of the scatter plot from the applet. Be sure the axes are well labeled. Rather than drawing each dot, you should just draw an ellipse shape where most of the points lie. Show that you understand how a scatter plot is created by making a dot on scatter plot corresponding to Wimbledon winner in 2019 is 188 centimeters tall. So for this, we're looking for, from the Zai book, something like that. You don't have to draw all the dots. We're looking for the oval that kind of gives you the main idea of the trend. Okay, now, so first we're going to talk about direction. So is the association between between year and winning height positive or negative? Interpret what this means in context. So in context, you should be talking about Wimbledon winners, the context of our data. Okay? Okay, so the form of association between two quantitative variables is described by whether a line would do a reasonable job, or if something curvy would be better. And when you don't know, go for line. Okay? So form, does the association between year and height appear to be linear, or is there strong evidence suggesting the relationship is nonlinear? So it's either linear or there's evidence it's nonlinear. Okay. Then the strength of association would be how closely the points follow the form, how closely the points follow a straight line or curve. So looking at this in our for number 12, I'm going to grade this. I should grade this kind of give you a lot of leeway here, because describing the form is hard at first when we haven't even taught you how to calculate a way to measure it. But this is trying to get you to understand how your common sense relates to the calculation. So just looking at those data points, describe the strength of the association. Okay. Then number 13, are there any unusual observations? So example from the Zai book was once you kind of like circle the trend, then the things that are far away from that oval, like these guys are not really unusual really, but this one and that one that are very far away from the trend would be unusual observations. So is there anything like that in our data? Okay. Now there's two types. There's two, not even types. There's two descriptors of unusual observations. They're influential if moving that single point changes the way you think about the association, and outliers are ones that don't follow the pattern. Okay, so the key idea is that association between quantitative variables can be described with direction, form, and strength. So direction, form, strength, and unusual observations. And going back to the Zai book, if you look at like describing it right here, direction, positive, form, linear, strength, fairly strong, unusual observations, yes. Like turning those into full sentences is like the way to answer some of the problems coming up. Okay, now numerical summaries. So now we're talking about the correlation coefficient. It's usually described with the correlation coefficient, usually described with lowercase r or capital R's. Depends on the textbook and what people's preferences are. Okay, and so there's in this paragraph it tells you like what values of r are strong correlation, what values of r are moderate, and what values are weak. So will the value of correlation coefficient for the year in height data be negative or positive? Why? So without even having calculated it, you should be able to see if it'll be negative or positive based on the trend in the data. Okay, because if it's trending up, it should be positive. If it's trending down, it should be negative. So for instance, in the Zai book over here, this association had a positive correlation because it's trending up. Okay, so the correlation coefficient uses a rather complex formula that's rarely computed by hand. Instead, people almost always use a calculator or a computer. So we're not going to focus that much on calculating it. We're going to focus on interpreting it. Without using the applet, give an estimated value of the correlation coefficient. So again, I'm going to grade this really easily. I just want you to guess something that's somewhere in the right ballpark. Okay. Now, check the correlation coefficient box in the applet to reveal the actual correlation coefficient. So, where is that guy right here? Correlation coefficient. Okay. So, there it was. Okay, now, so report that value. All right, the correlation coefficient is only applicable for data with which has linear form. Okay, so this is important. Nonlinear data are not summarized well by the correlation coefficient. That's going to show up. There's going to be one question related to that on the final exam. So be remembering that. Okay, now number 17. In the add remove observation section of the applet, enter year of 2020. Okay, let's see. Okay, so show data options. So you can click on a data point and you can delete data points. And so by deleting an arbitrary number, I'm going to make it so that the numbers I show you are not the answers. Although it might be close. Might be fairly close. Okay. Yeah. I'm going to delete some of these that are getting in the way of the correlation coefficient. Alright, now my correlation coefficient is different from yours. And then I'm going to add something. I'm going to add x is 2020 and y is 140. Okay. Note how this is an unusual observation on scatter plot. How the correlation coefficient changes result. Well, how does the correlation coefficient your app shows now? Mine will be different from yours. How does that compare to the one you wrote down for the earlier question? Okay, so for 18, this correlation coefficient is not particularly strong because there's a lot of scatter variation about the regression line. So just another variable we haven't considered yet. So this corresponds to, so number 18 should go with hopefully the thing you guessed for some reasons, a reason that some years have 2, so number 7. So 18 should relate to number 7. Okay. So, so here, if we look at the data and then color it by male and female, we get something else, something new. Okay. How do the male heights tend to compare to the female heights? Okay. Use your saying something quantitative there. Okay. Number 20, does the association between height and year seem to be similar between males and females? Okay, so we're just, we'll calculate the correlation coefficients for each group soon, but, just using your eyeballing it and using your common sense, does the association seem pretty similar? Okay, and then there's scatter plots of each one individually. So describe the strength, form, and direction of the scatter plot for female Wimbledon champions. Are there any unusual observations? So, so female and male. Okay. Notice the different axes when we graphed the females and male with different scatter plots there. Okay, so you should use the same sort of, like when you're describing an association, use these four, check these 4 boxes. Are you describing each of these 4 things? Okay. Now for number 22, do the same thing for male champions. Okay. For 23, what do you predict for the value of the correlation coefficient between height and year for female winners only? Why? What do you predict for male? So then, this is just a guess. So you just need to be in the right ballpark. I'm not going to grade this one very harshly. Okay? So the actual correlation coefficient for females is 0.4 and for males is 0.36. Explain to a non-statistician why the correlation coefficients are different within the male-female groups as compared to the overall correlation of 0.19 based on the pattern of the dots in the scatter plot. So, explain as if you're explaining to your roommate who's not taking stats about how when you have all these dots, then they don't fit a good pattern, but then the blue dots fit a pattern and the orange dots fit a pattern. Those patterns are stronger than the overall pattern of both groups together. So try to explain why that might be true using try to avoid using stats words. Just try to use smaller words. Okay. Now step 4 and 5. So for number 25, how does the strength and direction of association compare between men and women? What does this tell us about the pattern of height of Wimbledon winners over time? Well, the fact that the correlation coefficient is positive instead of negative should tell us something, and the fact that it's a little bit stronger should tell us something. Okay? And that's the key words there was what to expect. We're avoiding, when we're talking about what we might expect, we're avoiding causation language. Whereas in number 26, Can we say that the year causes change in the height of Wimbledon winners? Why or why not? This should relate to an earlier question from like the first couple questions of this worksheet. Okay, look back and ahead. Number 27. Name one additional variable you would like measured on each Wimbledon winner and explain why. So this one, use your common sense and knowledge of the world. Number 28. Describe how you could do a similar study for another sport. What two variables would you collect? What would you expect to see? Why? What third variable could also be measured by and be important to consider? So just make sure that you are actually like picking something and you're using complete sentences for this question. Okay, then and that finishes that section. So here we are.